Hello, Math 1050. This is Mrs. Bricky, and this video is for section 3.7 on variation. There are three topics in this section, and they're all pretty closely related to each other. So variation is a type of equation that we can set up. So if we say y varies directly as x, that means y is equal to a constant times x. And in this little equation, I have the constant as k. And if y varies inversely with x, that means that y is equal to a constant divided by x. So again, I'm using the constant k there. K is called the constant of variation. And the situations, these two equations up here are both pretty basic equations. They just have the three parts, the y, the x, and the constant. But the situations can be more complicated. For example, y could vary directly with one or more variables, and that's called jointly. And it could be varying inversely with another variable, and also any of the variables could have a power. So as you work with these variation problems, watch out for the word squared in your sentences. An example of maybe the most complicated type would be something like this: the drag force on a boat, so I've got F for force right here, varies jointly with the wet surface area of the boat and the square of the speed of the boat, and inversely with the weight of the boat. So the inversely one, the weight, is on the bottom of the fraction. The two that are jointly are on the top, the area and the square of the speed. And then, of course, we have that constant of variation there. So the steps that you'll go through for solving in these three topics are as follows. First, you're going to use the sentence to set up an equation, and you'll use the given information to solve for k. So it'll give you enough information that that k will be the only thing you don't know, and you can figure out what k is. And then it will have another sentence at the end of the question, and that final sentence will give you some other information, but one bit of information will be missing. That's what you'll be solving for, but you'll need that k value to finish solving. So there are three topics in here. The first one is called word problem on direct variation. Then there's word problem on inverse variation, and then the third topic is word problem on joint variation. Or I think it says, sorry, not joint. It says combined variation. Okay, so for direct variation, our first one, the amount of allergy medicine that a physician prescribes for a child varies directly as the weight of the child. Now, personally, I like to use letters and variables that correspond with what they stand for, just to help me figure or keep track of everything. So I actually personally don't like to use X and Y here, but you could use X and Y if you like. I just think it's easier to keep track of things if I use other letters. So the amount of allergy medicine, so I'm going to do M for medicine. The medicine is equal to, and this is varying directly, so it's a constant multiplied by the weight of the child. So again, you could have used Y and X, but I like to use the letters that stand for what it is. It just helps me keep track. So, clinical research suggests that a 13.5 milligram dose of the drug, so that's the medicine, should be given to a 30-pound child. That's a weight. So, those two numbers, if I put them into the equation, will allow me to solve for k. So, 13.5 is equal to k multiplied by 30. So if I divide by 30, I can solve for k. So in that case, when you divide both sides of the equation by 30, you get k is equal to 0.45. So now we know what k is. All right, so now we have two follow-up questions. How much should be prescribed to a 50-pound child? So that is a weight, that's a W. So we have this equation that we wrote right here, and now we know what K is and we know what W is, so now we can solve for M. So M is equal to K multiplied by the weight, K multiplied by 50. So in this case, the amount of medicine is equal to 22.5 milligrams. So sometimes you might be solving for your independent variable, which for me was M. Sometimes you might be solving for the independent variable. You've got to read the words and decide what it is asking you to solve for. So in this one, it says, or my question is, for what weight is this dosage appropriate? So we're going to solve for W, and it says that the nurse wants to double check the dosage on a doctor's order of 18 milligrams. So that is giving us the amount of medicine. So again, we know what the constant is. So if we use that equation that's written in blue, we have 18 is equal to my constant K, 0.45, multiplied by W. And in this case, W is like what I'm trying to figure out that I don't know. So if I need to solve this for W, I would simply divide both sides of my equation by 0.45, and I get 40 pounds. So that dosage is appropriate for a 40-pound child. All right, so that's kind of how direct variation works. You'll have a really kind of basic equation with that constant. You'll have to figure out what the constant is, and then you can use that to answer a follow-up question. All right, so with inverse variation, here we go. The loudness of sound measured in decibels varies inversely with the square of the distance. Again, watch out for the word square. So it's the inversely with the square of the distance between the listener and the source of the sound. If the loudness is 17.92 decibels at a distance of 10 feet, what is the decibel level 20 feet from the speaker? Okay, so we need to set up our base equation, and then we will figure out our K, and then we will answer our final question. So our base equation, the loudness, so I'm going to use L, the loudness varies inversely, so that's K over, and the thing that it varies inversely with is the square of the distance, so distance squared between the listener and the source. Okay, so we've got our base equation set up. Now I'm going to use the information in this first part of the sentence to solve for K. So this says the loudness of 17.92 corresponds with a distance of 10 feet. Well, in my equation, that's going to be 10 squared. So if we solve for K, we would multiply both sides of our equation by 10 squared, which is 100. And so we get 1792 is equal to K. All right, so using this base equation again that I started with, I now know what K is, and I'm going to answer my final follow-up question. What is the decibel level 20 feet from the speaker? So that 20 feet is a D. So I'm finding a loudness. The loudness is equal to my constant, 1792, divided by 20 squared. And so that means that my loudness is 4.48 decibels. Just really watch out for squares on this. So we had to use squares on our distance because of that word square. So really watch out for the word square on these. All right, so that's inverse variation. That's where you're going to set up a little equation involving a fraction with your constant on top. The last topic is a word problem on combined variation. This is where you may have some variables on top, variables on the bottom, just variables all over the place. These ones are definitely more challenging to set up. So we're going to use the first part of the sentence to write an equation. The force needed to keep a car from skidding on a curve varies inversely. So I'm going to use F for force. Watch out for situations where you have like two words that start with the same letter, and then you'll have to think more carefully about what variables you use. The force needed to keep the car from skidding varies inversely as the radius of the curve. So we've got inversely as the radius, and jointly as the weight of the car and the square of the car's speed. So we've got weight and speed squared. Jointly will be on top. It just means there's more than one. So it instead of saying directly, it says jointly because there's a couple of them up there. All right, so we've got our equation set up, and now we are ready to use the information to solve for K. Suppose a 245-pound force. So just be careful that that 245 pounds of force is not the weight of the car. That is the force. So watch out for stuff like that. Keeps a 2,000-pound car. That's my W. This was my F. So a 2,000-pound car from skidding around a curve of radius 600 feet at 35 miles per hour. And that 35 is my speed, and that in the equation needs to be squared. Okay, so if we solve that for K, which probably you could just do in your calculator, you can write out some steps if you need to, like multiplying by 600 and dividing by 2,000 and dividing by 35 squared, but I think that y'all are probably experts at solving stuff like that. So if we do solve for K, our K is equal to 0.06. Okay, so now we have our final purpose, which is to answer our question, what force would keep the same car from skidding on a curve that has a radius of 900 feet at a speed of 45 miles per hour? So our question that we're trying to answer is what force. So that's our variable that we don't know. We know that our K is 0.06. This is the same car, so it still weighs 2,000 pounds. And then our speed is now 45, so that's a 45 squared. And then the radius of this new turn is 900 feet. So we just need to substitute all of those things that we know in. We can crunch that into our calculator, and we get that the force is 270 pounds. And that is our answer, our final answer. So for these topics, you really will just have one number that you need to type in, but you kind of have three steps. You got to set up your equation first. You got to figure out your K value second. And then finally, you can use that K value and the other information to answer your final question. All right, so let me know if you have any questions. That is it for section 3.7. Thank you.